Here I have Unit 8, Section 5, Example 2, that says prove the two triangles below are similar. Then find the length of DE. So when I'm looking at this picture, the first thing I notice is that I have, for triangle CDG, I have 3.25 for a side and I have 1.25 for a side. But when I'm looking at triangle CFE, I only have 5 as a marking. I don't have any other side lengths that are shown. Because of that, I know right away that I have to be working with angle again. So in this problem, I'm going to go ahead and I'm going to start with the markings that are given to me. So I have this right angle marking on two angles. So I can go ahead and say that those angles are congruent because they have that marking there. So my first line is going to say angle CGD. Angle CGD is congruent to angle CFE. And I know that because it is given, but I also know that because of the definition of a right angle. Whichever reason you choose to use in this proof will be fine. I'm going to go ahead and I'm going to write given because it is given to me. So for my second line, I need to find a second angle that I can say is congruent in order to complete my angle-angle triangle similarity theorem. When I'm looking at these pictures, I notice that angle C is in both triangles. So I'm going to go ahead and I'm going to say that angle C is congruent to angle C by the reflexive property. And I'm using the reflexive property because that property allows me to say that something is congruent to itself. So now that I have been able to show that I have two sets of congruent angles in these triangles, I can go ahead and say that they are similar. So my third and final line of my proof is going to say that triangle CGD is similar to triangle CFE by the angle-angle triangle similarity theorem. Now that I've shown that I have two similar triangles, I can go ahead and I can tackle the problem of the missing side length. So it tells me to find the length of DE, but when I look at these pictures, if I'm going to set up a proportion, that's actually a little bit more than DE. So I have FE, which is 5, and 5 on FE goes to the whole triangle of CFE. So I'm really looking at the full length from C all the way to E. But I already know the length of CD is 3.25. So what I really have is this unknown piece that I'm going to call X plus the additional 3.25, and that's going to give me my full length. So that's going to be the bottom part of that ratio, is X plus 3.25. So now that I have the ratio for the bigger triangle, I'm going to go ahead and I'm going to set it equal to the ratio from the smaller triangle, triangle CGD. In triangle CGD, I have 1.25 for the side length that should be proportional to FE, and I have 3.25 that should be proportional to that full length from C to E. Now that I have my proportions set up, I'm going to go ahead and I'm going to solve by cross multiplying. So as I'm cross multiplying here, I have one side that I have to do some distribution. So I have 1.25 that I have to multiply by both X and 3.25. I can't just multiply by one, I need both pieces. So when I start with the X, I have 1.25 times X, that just gives me 1.25X. And then I'm going to add that to my 3.25, which is multiplied by 1.25 as well. So when I type in 1.25 times 3.25, that gives me an answer of 4.0625. I'm going to go ahead and I'm going to round to 2 decimal points. So I'm going to say that 1.25 times 3.25 is 4.06. And that leaves me to solve my other piece, which is 5 times 3.25, which gives me 16.25. Alright, so now I need to get X by itself, and thing that I want to move first is the piece that's easiest to move, which in this case is the 4.06. I'm going to subtract 4.06 from both sides, and that gives me that 1.25x is equal to 12.19. Okay, I still need to get x by itself, so I'm going to go ahead and I'm going to divide out 1.25 on both sides. And that gives me that x is about equal to 9.752. And I'm going to stick with rounding to 2 decimal points, so when I write my final answer of DE, I'm going to say that DE is about equal to 9.75.